Welcome to Software Testing News, the place to go to for all your computer science and software related information. I'm your host, Peter Lawson, and I'm very glad you could join us tonight. Today, we've got a very special guest for you. Barton Miller is a professor of computer science at the University of Wisconsin. He's in our studio today to discuss the pioneering research that he's done into fuzz testing and speak to our reporter, Georgina. Over to you, Georgina.
Thanks, Peter. So, Barton, firstly, tell me, what is fuzz testing?
Fuzz testing is a simple technique that is capable of having a profound impact on a developer's code and the ability to find and resolve bugs. It is used to discover coding errors and security loopholes by inputting massive amounts of data, which we call fuzz, in order to see if it will make the system crash.
Very interesting. Can you provide us with an example?
Sure, Georgina. An example of its use could be, well, let's say on a program that asks the user to select between three questions. When the selection is made, traditionally we would expect the choice to be, say, either 0, 1, or 2. However, what would happen if 3, or even say 255 is transmitted? We need to make sure that the program is able to handle this in a switch case that doesn't cause issues like buffer overflow.
Right. So can you tell us, where did fuzz testing originate from?
Well, fuzz testing originated in 1988, where I developed it at the University of Wisconsin as part of a class project. The project had two parts. The first involved the students creating a fuzz generator. The fuzz generator is a program that creates a random character stream. The second part involved using this fuzz generator to attack as many Unix utilities as possible. The aim being to break these Unix utilities with the fuzz generator. We later found out from the results of this project that between 25 to 33% of the utility programs on any Unix version that was tested ended up being broken through this method.
So what do you think the main advantage of fuzz testing is?
Well, Georgina, a big advantage of the technique is that due to its randomness, it is completely free from preconceptions about system behavior and has no knowledge of how the system should be responding. This can be advantageous as it removes any sort of bias that a human may have when they perform testing, as a human can be distracted by looking for what they are expecting to find.
And Barton, are there any disadvantages to fuzz testing?
In many cases, fuzz testing can only demonstrate that a piece of software can handle exceptions without crashing rather than checking if it is behaving correctly. It is therefore an assurance of quality overall, but can't be used to replace any other formal techniques for finding actual specific bugs. Fuzz testing should not, then, be the only testing technique that is utilized on a testing project, but instead be seen as an additional tool in a software tester's repertoire. The randomness has also been seen as a disadvantage by some, as catching a boundary value condition from random input is quite unlikely. However, this is another problem that only seems to be of concern if fuzz testing is relied on as the sole technique for testing. There are other techniques that can be used for boundary testing values too, so if fuzz testing is treated as one of the many tools rather than the sole testing instrument, it seems that this should not be much of a factor.
Well, that concludes our time, Barton.
Well, thank you for having me, and I hope my answers were clear and not too fuzzy for you. What?
Back to you in the studio.
What a fascinating subject. I know I've learned more. Thank you, Barton, for taking time out of your busy schedule to teach us about fuzz testing. And thank you at home for joining us, and we hope you can make it next week, where we have a special on IBM's automated testing software. Good night.